Hello my dear children of class 12 science. Today we again do continue with the chapter, the second chapter that we started from last class, a very short chapter, as I said also, nuclear structure. Okay, so in the last class we studied about the composition of nucleus, okay, the nuclear size, the nuclear density, nuclear shape, okay, atomic masses, and most importantly the unit which is used to measure the mass of the atom, nuclei, electron, protons and all, that is called unified atomic mass unit, or we simply call atomic mass unit. Now in today's class we just do continue with the topic energy equivalent of 1u. One small u means, as I said, unified atomic mass unit. Now the mass of atom, nuclei, okay, subatomic particle like a proton, neutron, electrons, this can be calculated by the smallest unit, okay, and this unit is called atomic mass unit, or we also call as unified atomic mass unit. And in the last class, like in yesterday's class, we had done up to the relation, then one atomic mass unit, that is 1u, is always equals to 1.6605 into 10 to the power minus 27 kg. Yes, we had done up to this. That means unified atomic mass unit can be expressed in terms of kg. As you know, kg is also the unit of mass, the SI into mass. But one atomic or unified atomic mass unit can be expressed in terms of kg also. Now look at the power. From this power only we can say that how small this unit is. That is minus 27. Okay. But we now going to measure the energy equivalent of one atomic mass unit. Now for this energy to be measured, we just go back to the concept of Albert Einstein's. Now Albert Einstein made an observation, okay, saying that in a universe, every particle or body which has mass, that has energy also. Okay, every particle or body which has mass, whether that body is at rest or in motion in any stage, okay, that body also has what? Energy. So if there is energy, there is a certain mass, then there is a what? Energy. Okay, so for that, suppose if there is a mass, very small mass, that is what? Delta m. So if this is the delta m is the mass of a body, and you learn this in the next chapter, okay, as a mass defect. Okay, but as for the Einstein's relation and the observation is concerned, that if a body has a mass, say delta m, okay, then the equivalent energy is measured by, say, delta E, and this delta E is equals to delta m into c square. You can write this way also, or you can write this way also, like E equals to mc square. If a body has simple mass, say m, then the energy corresponding to mass m is given by E equals to mc square. And this is a famous Albert Einstein's relation, and this relation is called Einstein's mass energy relation, or mass energy equivalence. That means energy in the universe for a body of any amount of mass is measured as E equals to mc square. And the details of this energy mass equivalence part you learn in the next chapter, and there is a chapter for this only, that is called energy mass equivalence. Okay. Now we are going to use this relation formulated by Albert Einstein to measure the mass of this this particular, with respect to this particular mass, how much will be the energy. Because this particular relation is very important when we come to the calculation and numerical based on the energy to be calculated, and this energy which we will calculate now will also in what? Mega electron volt. So I'll tell you what is mega electron volt. Okay. Now for that, c, this c is the speed of light. So children, in this relation, c is the speed of what? Speed of the c is the what? Speed of what? Light. Okay. Now, as for the calculation, delta m, let me take delta m or m, no problem. You can write delta m also or m also. Okay. Is how much? 1u. This 1u. Okay. But as I said, 1u equals to how much? Kg. So I write this in kg only, that is 1.6605 into 10 power minus 27 kg. So if a mass is one atomic mass unit, or which is equivalent to 1.6605 into 10 minus 27 kg, then the speed that we take is the approximate, the experimental speed which was calculated, okay, and that we take as 2.9979 into 10 power 8 meter per second. So children, this is the accurate or speed of light in what? Air or vacuum. But you know, we usually round up this value to 3. We write 3 into 10 power 8 meter per second. But as for the experimental result, okay, the speed of light in air or vacuum is measured as 2.9979 into 8 meter per second. Okay, so if this is the speed of light and this is the mass, okay, then the energy can be calculated. So to calculate the energy, therefore I write down delta E, or you can write E also, no problem. It's given by the formula delta M, or you can write M only into what? C square. Now delta M or M is how much? 1.6605 into 10 to the power minus what? 27 into, now speed, you can see the speed, we put this value 2.9979 into 10 to the power 8 with whole square. So with this speed, now we can calculate, okay, the value of what? This energy. But we calculate this energy usually in what? Joule. Because we are measuring this mass in kg and this speed in what? Meter per second. So definitely with this relation, we calculate the energy in what? Joule. Now let me just do the calculation. So 1.6605 into now 2.9979 square. If you multiply it 2 times, you get approximately 8.9874. So children, you can use calculator to check this product, that is 2.9979. Okay, so it will be 8.9874 into 10 power minus 27 into 10 power. Now 8 to the what? 16. Okay, 8 to the what? 16. Now we can multiply these two quantity. If we multiply these two quantity, you get approximately 14.924. So approximately in 3 decimal place we get this in as 14.924. Okay, so you can check with hello calculator. Into 10 to the power. Now let me subtract the power. The bases are 10. Minus 27 plus 16 means minus 11. Minus what? 11. Now this will be in what? Joule. That means the energy which we have calculated corresponding to 1 U, 1 atomic mass unit, is 14.924 into minus 11 joule. But children, let me just tell you, joule is the SI unit of energy. But this is not the smallest unit of energy. The unit of energy can be expressed by the smaller unit also. Okay, by the what unit also? Smaller unit. As you have learned, let me just tell you, the energy can be measured even by the unit called electron volt. What? Electron volt. And 1 electron volt is usually how much? 1 point. The accurate value I am telling you, writing out here 1.6022 into 10 to the power minus 19 joule. But when we take this value in 1 decimal place, we take 1.6 only. But I am writing the experimental value of 1 electron volt. 1 EB means 1 electron volt. It is 1.6022 into minus 19 joule. Okay. But the energy which we calculate of any mass, equivalent to any mass, okay, we measure basically in what? The mega electron volt. So the unit which we write, measure this energy is what? In what way? Mega electron volt. Now 1 electron volt is 1.6022 into minus 19 joule. Now mega means usually higher than electron volt. And you know 1 mega electron volt means 10 to the power 6 electron volt. Because mega means higher than electron volt. And you know what is the order of mega? 10 to the power 6. That's why 1 mega electron volt is 10 to the power 6 electron volt. Okay. Now 10 to the power 6 into now electron volt. 1 electron volt is this much joule. So let me substitute. It's 1.6022 into 10 to the power minus 19, and the unit is what? Joule. Okay. Which means 1 mega electron volt. Now we can even write as 1.6022 into 10 to the power. Now 6 minus 19 means minus 13. And the unit is what? Joule. So look at this. 1 mega electron volt is how much? 1 mega electron volt equals to 1.6022 22 into 10 minus 13 joule. Okay, so this is the relation between mega electron volt and joule. But the energy that we have calculated out here, you can see this is the energy. Okay, you can see I write in this box. Okay, this energy which we have calculated in joule corresponding to mass of one unified atomic mass unit. But I convert this joule into what? Mega electron volt. So usually what you need to do? So to convert mega electron volt to joule, we need to multiply by this factor. Okay, but to convert from joule into mega electron volt, I divide this factor. So children, look at this. This part is important. To convert joule into mega electron volt, divide by 1.6022 into power minus 13 in this relation. So the energy will be now equals to how much? 14.924 into 10 minus 19. I divide by 1.6022 into minus what? 13, and this will be in mega electron volt. So calculating the energy in what? Mega electron volt. Now with the help of calculator, if you divide this quantity, so this decimal point 14.924, if you divide by 1.6022, you get approximately 9.315 in 3 decimal places. 9.315 into 10 power, this is minus 19. Now minus 13 if I take in a numerator, plus 13, and this will be mega electron volt. So let me just continue with the calculation. So the energy which we are calculating is 9.315 into 10 power. Now minus 19 plus 13 means how much? Minus what? I'm so sorry for this, children. Just let me do correction. It's not minus 19, it's minus 11. Sorry, it is minus 11 out there, because there's 10 minus 11. So this is 10 minus 11. Okay, so please do correct out there. So 9.315 into 10 power minus 11 plus 13. Means 13 minus 11 is 2. So 10 power 2. Now we calculate this energy now. 9.315 into 10 power, as I said, 2. And this is in mega electron volt. Okay. So if you multiply, means 10 power 2 means 100. So it's 931.5, and the unit is mega electron volt. So look at the energy that we calculated now. So what is the energy of a mass, one unified atomic mass unit? Equivalent energy, that is 931.5 mega electron volt. Means if a body acquire a mass, that is one unified atomic mass unit, how much equivalent energy that will be liberated or released from that body? As per Einstein's equation, 931.5 mega electron volt. Okay, so as far as the relation is concerned, now I write down, therefore energy, therefore the energy, okay, equivalent, therefore the energy equivalent to 1 U, U means atomic mass unit, is given by 1 unit. If the mass is 1 atomic mass unit, the equivalent energy is equals to 931.5 mega electron volt. Okay, and 1 atomic mass unit, as far as the relation is concerned, it is written as 1 U into C square, is 931.5 mega electron volt. So this relation, children, is very important, especially for the numericals. So remember this, when the mass of any body in the universe is equivalent to 1 unified atomic mass unit, the how much equivalent energy that will be released from that body, or how much energy that is produced by that body? 931.5 mega electron volt. Okay, so this relation concerns that in the universe, mass and energy are always interrelated to each other. They are always interrelated to each other. That means mass and energy are not a separate entities. Okay, they are not separate entities. That means they are always interrelated to each other. Just like electricity and magnetism, as you have learned, are interrelated to each other. Similarly, in the universe, mass and energy are also interrelated to each other. So this is the relation that I have derived for energy equivalent of 1 unified atomic mass unit. Now in the next YouTube video, we deal with the topic called nuclear reaction. So this is the last topic that we learn, okay, from this chapter.